After completing this video, you should be able to explain the purpose of the build utility, use the build utility to verify project validity, and identify 5 common build errors. The build utility allows programmers to do running spot checks on their logic without downloading it to the PLC. It also won't let you download if there's an error. The build process verifies that there are no errors that can result in a major fault on the PLC. With the build utility, when errors are detected, the software will generate a report. And the report lists all the discovered error. Each red circled X is a link to the actual error. You just need to double click it. Alright, so we've talked about the build utility that will detect errors and problems in your program. So I'm going to do a quick build on this, and I have a few errors that are quite common. And the first one I like to call the unidentified flying variable. And our first mistake says new variable .1 undeclared identifier. And that sounds rather cryptic, but it's actually quite simple. So we're going to double click on it. And that's going to take us right to the error, and it's always going to be in a yellow backgrounded box to really draw attention to it. I sometimes think they're mocking me, but that's okay. And I'm going to click on it, and you can see where it says new variable .1. So the period is a delineator between the name of the variable and one of its members. So this must be a construct. So let's right click and see why this is not acceptable. Go to the variable selector, and under program it's saying bool. Well, you can't have a period because a period, as I say, identifies a construct that has members in it, and a bool has only one member. There is no construct. It is a complete whole party. So let's get rid of the filter, and what we're going to do is I'm going to get rid of that .1 because that's what's really affecting us, and I'm going to change the data type. It's happy with that now, but I'm going to change that from a bool to a dint. Now normally we think of a dint as being a 32-bit sized chunk of memory, but we can use it as a construct and look at the individual members. All we have to do is hit that little arrow, just like we have with timers. Timers have their members in it. Some of it's bool, some of it's time. Well, a dint has members too. All the members are individual bools, and they're delineated from the variable name by that period. So now I have new variable .1, and if I select that, you'll notice OK it goes from gray to OK, I'll accept that, and my attention triangle has disappeared. So when you see it says unidentified, let's go back to our error list, unidentified or undeclared identifier, that means you have not created that variable, or you've not created it properly. Alright, now that we've resolved one of our issues, that amber color box is going to hang around until next time I open the project up. But I'm going to, let's do the same thing again. Let's see if I've reduced the number of arrows I've got. And now we have number 2, undeclared identifier, the missing person known as undeclared identifier. Okay, let's double click on that and see where that takes us to. And now it's highlighted the timer, and it's our PT, that's our program time. I've got the T and I've got the hashtag. So the T hashtag combined tells the CPU, okay, what you're going to read after that is going to be time. Time can be measured in milliseconds, seconds, minutes, hours, days, and years. Oh, okay, hang on a second. What are we counting here? Are we counting 2 days or 2 years? Or so what's happened is, in the rush to get things done, the person who programmed this, and I'm not going to say who, although you're probably listening to them, I'm just going to put the letter S after that and say this is a 2-second timer. And let's confirm that that's actually fixed it, because it doesn't ever hurt to run this build utility as many times as needed to clear up all the errors. And I don't see it anymore, and I went from 4 errors down to 2, so I'm well on my way to fixing this up. Alright, so we're going to look at the next error, and it says expecting an output or memory bool variable. Okay, that sounds kind of cryptic. Let's double click on that. Now, here's a bit of the clue, but let's double click on that. And it's down near the bottom. We'll zoom up. Okay, so I've got TON_Q. That's okay. That's a done bit from the timer. Okay. It's complete will energize the relay. Okay. Notice here in the commentary, it's supposed to be digital out 02, and I have digital input 02. So this particular error, see how it's saying expecting an output or memory bool variable. So the coil works only on bools. It does not work on dints. It doesn't work on anything but a single bit. So that's not the problem. The problem is that I've asked for an input, and you cannot have the PLC turn on an input. It has to see that from another source. It'd be like trying to short it out, which is not what you want to do. That's a bad thing. Now, some PLCs have had the ability to put a 1 in what they used to call the image table, and you could trick it for a scan, and then other PLCs you could actually write an output turning on an input so that the input would be true in the logic. But those are the exception, not the rule, and this is considered to be very bad form. And it's a simple fix. We just simply have to click on it, and notice that in our selection, because it's an output, it's going to give us the output choices that are available to us. And if I were to select this one, 2, oops, I don't want the warning horn, I want 2, okay. Now, this is perfectly acceptable, and it's even showing me the coil name, that the alias, the control relay. Now, the only problem is you have to be careful when you're doing these outputs that you don't double name it. I almost put number 3, and I'll show you what happens. So now I have digital output 3, and the next rung is also digital output 3. Now there's another video called duplicating errors. It's an error of a duplicate output will not be caught in a build. It'll be caught when the program fails and something goes boom or crash or doesn't do what you want it to do. So for now, I'm going to put that back to where it's supposed to be. It was digital input 2, I want digital output 2, and I'm going to hit my build again. Let's see if I've reduced the number of errors I've got to fix. And according to this, I'm down to a single error. Alright, according to this, we have one more error to fix. Expecting an output memory or bool variable. Okay, let's click on that and find out what they're trying to say there. And it's jumped to here where it says conveyor. Now there's nothing after the conveyor, and it's an output. So let's see, I've got TON. Okay, that's fine. Turn on output. Okay. Oh, that's just DO4, which is not really what I've got here. But why is this giving me an error? That's... Oh, let's put that back on there and see where it says didn't. This is of a case that you cannot put a Mack truck in an orange. You can't fit something that doesn't, well, it has to be the right size. So let's right click on go to variable selector and see where we're getting into some trouble here. By default, it's going to take the name I've typed and it says, well, we're expecting a bool. And you have a dent, which is not correct. So let me open this up for a second and let's take a look, get rid of that filter. And we have a bool called conveyor, so that might be okay. So why would that be giving me grief? Well, let's change the scope. Right now, we're only looking at the variables that are located in the local variable collection. And that local variable is specific to program 1. But let's go to the global variables and see what we end up with. Cancel that. Open up our global variables. And if I scroll down, there it is. There's conveyor, and it is indeed a dent. So, how do we rectify this? Because we don't want to have 32 bits stuffed into a single coil. That's not going to work for us. So we're going to use the construct method here, and it is a dent, so I can open it up, and you can see I have all 32 conveyors. And I called that one conveyor 0 or conveyor 1. I tried telling it to put all 32. It would be a neat trick that you turn on one coil and 32 conveyors start to run, but I think that would not be good. So I'm going to make that conveyor 1. I'm going to ignore conveyor 0. By doing this, I can write internal logic and control 31 different conveyors. When we get into the problem of the duplicate outputs, this is where you can do the similar idea, only in that case we're going to use another trick that will avoid it, which is related to this. So I'm going to use conveyor 1, double click on that. So let's go back to our program, and what we're going to do is I'm going to drag down until I see the word conveyor. Oh, it's just not going to let me do that. But because that's a global variable, I should be able to put a dot, and all of a sudden, the second I put that dot, it says, oh, you want something from this dent called conveyor. And I want conveyor 1. Now, what's interesting is I have two different variables by the same name. Let's go back to our local variables and see if that still exists. Create one called new variable, but the conveyor now is gone. In most instances, if you've used a variable up within a local, you can't reuse that. You have to get rid of it. However, I can use new variable in another program, because as far as the processor is concerned, this new variable belongs to program 1. If I create more programs, new variable, I can rehash that same tag. It will be confusing for the electricians trying to troubleshoot my madness, but it will work. When you do it as a global variable, one size fits all, you cannot repeat the same name. So let's go back to our program, and let's see if I've fixed everything up by doing another build. And build. Twiddle my thumbs. I have more work to do. Somehow it didn't catch my other error. Okay, so we have 2 errors, and it says T #5 must be a time expression, must precede a time expression. And it's the same line, same program, so they must be related. So let's click on that. And where do we end up? Don't see it. Okay, I got a warning here. Oh, referring to undefined variable, referring to undefined variable. Okay, so there's that period. Remember that a period represents a delineator. It takes the name of the variable and separates it from one of its members of its construct. I was attempting to program 5.5 seconds, but I can't do that because I have to use a period. And the PLC and the program says, I don't know what T#5 is. I don't have no idea what are you talking about? So again, this is an easy fix. And what I'm going to do is I'm just simply going to back that off, put an S for 5 seconds, and then I'm going to sneak and put an M in there for milliseconds. So now it's 5 seconds and 5, actually I want 500 for 5.5 seconds. Okay, that should be okay. It's happy with that. Let's do a build and see if I've cleared the deck of all my misgivings. And my build is now successful. Now these are some common errors that will pop up on occasion. And you can see how using the build utility will direct you right to it. Sometimes it's a little cryptic and you have to start thinking and looking at what you're attempting to do and what you've actually done. So you can clearly see the value of the build utility. It can't capture all possible errors. When we get into move instructions, you can actually move incorrect data that it can't foresee, and you can end up creating a major fault. But the build utility will stop any program carelessness or errors or forgotten variable names, etc. And it really helps to focus on the programming at the time. The build utility is quite useful for picking up errors of omission, errors of poor typing skills. It catches a vast majority of them, but there are a few of them that I want to go over. Most of them I'll go over in another video, but I'm going to capture a couple in a moment here. Now here's one it did catch, and I'm going to go over a couple of errors that aren't errors. Well, you'll see. Okay, so this one is expecting an output, and we have this rung with no variable attached. That's going to create a build error because it wants to have something attached. It doesn't know what you want to do. So that's just a leftover ghost rung. I call a ghost rung one that I might create a bunch of them and then go, okay, I've got my program tidied up and shrunk into a nice little package. I don't need these anymore. So that would be considered a ghost rung because there's no instructions, no variables assigned to it, etc. So that's an easy fix. We can just highlight and press the delete key, problem solved. Now these next two, rung 12 and 13. Rung 13 does have an output, does have a coil. Now this is called an unconditional rung. Now an unconditional rung is exactly as it says. As soon as you put power to it, that output's staying on. There's no way to turn it off except to turn the PLC off. It's not used very often. It has very specific functions, but make sure when you're putting an output that you have a way to turn it off. So in this case here, we would definitely want to have our digital input stop button. So at least pushing the button is going to turn it off. The rung above it, I have an input and I have no output. Now, the software will actually let you do this, and it'll actually let you download it to the Connected Components Workbench. But that happens to be a feature of this particular processor, this particular software. Even within the Allen Bradley family, I know from experience that this rung 12, is considered to be a dead short. If DI11 turns on, it's got nowhere to go but right to the rail. So the program will not normally allow you to do this. For whatever reason, Connected Component Workbench is happy with it. Try not to do this. This is a very bad habit to get into and will cause you grief and possibly fault things out. Rung 11 appears to be the same as rung 12 in that there is no output coil on the right hand side. Well, there actually is. I could duplicate that by putting the coil here, because this coil is actually this letter Q right here. That coil does appear. It allows you to put some instructions after the Q before the right hand rail as additional outputs. However, when you're learning to program in the first place, the best practice is to get used to how the timers work and do not put anything outside on the left hand side, or pardon me, the right hand side of the Q. Leave it blank. When I was first learning to program, we actually just put a bunch of these here because I want to get that in position to show you. The output, the timers themselves were always on the right hand side. They were never close to the left hand rail. So you had all your preconditions to make the timer actually do its job, and the output was actually shown as a little coil stuck on the side of it. Let me just put that back into perspective. On the side of it. And there was actually, on a timer there used to be 2. They're now built into the unit itself. But this is, when it comes to using timers, until you get proficient, I strongly recommend that you leave the timer where it is and then just create another rung that uses the Q, and you won't run into timing issues, and I mean that literally. So these are errors that are not errors. An unconditional rung is not an error, it's just a rung that's going to always be true. This is a unfinished, I'm going to call that an unfinished rung. I'm really going to have to learn to spell and type unfinished rung, because there is no output, and this is not an error, that is correct. So with that, thank you for watching the video. Will be upcoming ones on other errors such as duplicating your outputs, and we'll see you then.